Hi everyone, Lloyd Reber here again with our next example of using Excel to compute some statistics. In this video we compute the second of three inferential statistics covered in this course, namely the t-test for an independent samples design. This is a short video that builds on what we learned in the previous video tutorial on computing the t-test for a correlated samples design. So, if you have successfully completed that previous video tutorial, then you will find this video tutorial to be a snap. But if you have decided to take a look at this video without having first completed the previous one, then be warned that what you will find here will be very confusing. I recommend you stop, turn around, and go back. As I've said all along, understanding statistics requires us to build upon our previous work, and this video is a very good example of that. So, this video tutorial will be a short and sweet ride for those who are ready, or a very frustrating experience for those who are not. Okay, let's begin with a very short recap of the t-test formulas and a quick explanation of what we will be doing once we get to Excel. Here again are the two formulas for the two t-tests. And remember that in both cases, a t-test is a difference between means divided by the standard error of a difference. And with a t-test, you always only have two means. So last time we computed the t-test for a correlated samples design. And this time we're going to be computing the t-test for an independent samples design. In a few minutes we'll consider the conceptual difference between the two designs, and they really are quite dramatic. But for now, let's just consider the mathematical differences between these two formulas. And I need to point out a small correction that I've made in this particular slide that probably some of you who are quite astute have already noticed. In the formula for a t-test between independent samples, I only have x's. I've taken out the y's. Because really in an independent samples design, you have two separate groups, and those are better represented by x bar 1 minus x bar 2. The mathematics remain the same, but you'll see that I've updated many of the formula on this slide related to the independent samples t-test to show the x bar 2 in place of the y bar. So mathematically, what I need to update is the denominator, the standard error of a difference for an independent samples design. So you see it there, and if we jump down to the bottom, you see it there, and that is equal to the square root of the standard error of the mean of the first group squared plus the standard error of the mean of the second group squared. In our Excel spreadsheet, we'll be referring to that as sub x bar 1 and sub x bar 2, and we will be squaring both of those, which is really represented in the final part of the formula here, where you recall we calculated all of that based on the two standard deviations and the two n's, where n1 is the total number of people in the first group and n2 is the total number of people in the second group. When we move to Excel in a few minutes, we'll start by opening the Excel spreadsheet that we ended with in the previous video. And of course there we computed the standard error of a difference between correlated means, or S sub d bar. But of course the first part of that formula mathematically is going to be exactly equal to the formula for an independent samples design, except that we are not going to be subtracting that last part that contains the Pearson R. So by taking out that last part of the formula magically transforms from the standard error of a difference between correlated means into the standard error of a difference between means. So when we get to Excel, all we'll need to do is delete that last part of the formula. Although the mathematics requires just a little tweaking, conceptually we are making a dramatic change to the design of this particular experiment. Recall that with a correlated samples design, we are using only one group of people, and we give that one group of people two observations that we were calling a pretest and a post-test. Now, with an independent samples, we are going to have two groups, and it's going to be very important that all the people chosen have a 50-50 chance of being in either group 1 or in group 2. So the principle of random assignment is critical here. So this is called a post-test only control group design. So we have two groups. We are then going to give only the experimental group the treatment or activity or training program, whatever it might be. That is group 1. Group 2 is the control group, in that the people in group 2 do not receive the treatment. Then we will give both groups an observation, which we'll call the post-test, and then we will compute the means of the post-test of those two groups, which we will then compare. Recall that the null hypothesis is that there is no difference between the two group means. After we compute a t-value, we'll need to look up the critical value based on degrees of freedom to see if it is equal to or greater than the critical value, and if it is, then we will reject the null hypothesis. And if the mean of the experimental group, group 1, is greater than the mean of the control group, group 2, then we will conclude that the treatment did have an impact, or we might say made a difference in the learning of the people in group 1. Finally, we will need to make one more mathematical tweak in our Excel spreadsheet related to the degrees of freedom. Recall that in the t-test between correlated samples, the degrees of freedom is n minus 1, where n is the total number of people in group 1, or the total number of pairs of scores. However, for the t-test between independent samples, we have a degrees of freedom equal to n1 plus n2 minus 2, or the total number of people in group 1 plus the total number of people in group 2 minus 2. Well, this makes sense because we have two groups and we have different people in each of the two groups. We have, in essence, two n minus 1s that we are combining. Okay, I think we're ready to go to Excel to quickly make these changes. Let's go. Let's start by opening the Excel file we created and saved last time. Recall that the file title was our last name dash correlated t-test, and I used underscores for the spaces. So let's now go and save this with a different name. So I choose Save As. I'm again saving it to the Inferential Statistics folder that's located in our course folder. And all we're going to do is change the word correlated to independent. Making sure we're saving it to the right place, click Save. Once again, a reminder that I'm using the Macintosh Excel 2011 version. So if you are not, remember you'll have to translate my actions for whatever version you are using. Let's start by dealing with that conceptual change where we go from having one group of people being given a pretest and a post-test to two separate groups of people each being given a post-test. So let's start with some labeling. I'm going to go up to where it says pretest, and I'm going to change that to group 1. Press return. I'll go and click on post-test, and I will type group 2. And I could change the label scores to post-test, but I really don't see a reason to do that, so I'm just going to leave that alone. But it is very important conceptually to relabel how the students are identified. So in group 1, I have them identified as students A through J, but in group 2, they are a completely new or different set of students. So I'm going to go to change the labels there, starting with K, L, M, N, and so on. All the way down to T. So do stop and reflect on how those very small changes in labeling equate to a very dramatic or big change conceptually in the overall experimental design. Okay, let's finally make the mathematical changes that are needed. I'm going to go and click on the t denom value, the denominator for t, and I'm going to go up and edit the formula, taking out the minus and everything after it, but leaving one parenthesis. So take a moment, make sure yours looks like mine, and then press return. So the value of the denominator is now 2.83, and notice that the t value has now been updated to negative 2.29. Okay, just one more thing to do, and that is to update the degrees of freedom. So click on degrees of freedom, then click up in the formula to edit it, and I think it's going to be easier just to delete everything except the equal sign. And now we need to enter N1, the value, so I'll click on the 10, plus N2 minus 2. Press return. So the degrees of freedom are now 18. Well, according to my watch, it took just over a minute to make all of those mathematical updates. We have one more step. Now that we're equipped with the t value of negative 2.29 and degrees of freedom of 18, we need to go to a table of the t distribution to look up the critical value in order to see if the group 2 mean of 34.40 is significantly different than the group 1 mean of 27.9. Let's go and do it. Here's the table of the t distribution, and this is exactly the same table that we used in the previous video. Let me start by putting in our two values here. We have the t value of negative 2.29, and we have a degrees of freedom equal to 18. Okay, and a reminder that we are again using a two-tailed test with an alpha level or significance level of 0.05. So we now need to come down to degrees of freedom of 18, and we go and look at the intersection and see a critical value of 2.101. So the absolute value of our t value of 2.29 is clearly equal to or greater than the critical value of 2.101. Therefore, yes, this is a statistically significant difference between the two means. Of course, we better check our work, so let's compare the results of our Excel spreadsheet with those calculated with SPSS. Here's the output from SPSS, and of course there is a lot of data here, but let's just check out some of the key elements. So for example, here is our t value. It shows negative 2.293, so yes, that checks out. Degrees of freedom 18, that checks out. And finally we have a p-value or probability value of 0.034, which is equal to or less than the alpha or significance level of 0.05. So this also checks that this is a statistically significant difference. Well, that concludes this video tutorial on how to calculate a t-test of an independent samples design. I hope you are now feeling a great sense of accomplishment and satisfaction in knowing how to calculate different types of t-tests and how to use them in the evaluation of instruction and training. Until next time.